Hello, this is a short video to discuss the concepts of cryogenic chilling as applied to deep mining. There are a number of other avenues that we wish to go down, but we think the cryogenic chilling is the very first one to start with. So if, first of all, I can just give a big picture description. Cryogenic energy storage is currently being accomplished purely by arbitrage. So during the low energy price periods, cryogen can be produced, and then during the high energy price periods, the cryogen is expanded through a turbine to produce electricity for sale back to the grid. The interesting aspect of that is that by incorporating cryogenic energy storage into a mining project, that affords you the opportunity to be able to use wind turbines or renewable energy sources, but when the wind's not blowing, you simply use the stored cryogen to produce the electricity that you need. And now, the reason we think that incorporating the energy storage project into the mine is because of the economies of scale that would be provided to reduce the cost per ton of the cryogen being used for the other purposes. The main one of which we think is chilling. Chilling can be accomplished using a cryogen by simply pumping it from the surface to whichever level you want, and then converting it from a liquid to a gas. That process involves basically two steps. But the interesting thing is that because part of the cold is stored as a phase change, in other words, heat is absorbed by the cryogenic liquid for the phase change, that provides economies in terms of the transport of the cold. So the first step is basically the cryogenic liquid goes through a little heat exchanger and it absorbs about 205 kilojoules per kilogram of liquid moving through there. Then you have a gas, which is now at about 195, 196 C, and it has to be raised up to ambient temperatures. So this is in the neighborhood of 220 degrees Celsius when you go from there to ambient temperatures, say plus 20. So interestingly, the expansion for every liquid, for every liter of liquid, it provides about 700 liters of gas. So there can be power derived from that expansion in an underground system. And the current iteration of the cryofan that we're working on involves a system that will provide cool, but it'll also run itself. So the power is taken from the expansion of liquid. We think this is the important first critical step that has to be done and demonstrated to the mining community to show, because chilling is a major problem, especially as you get deeper. But following on from there, it's a very straightforward matter to produce compressed air. And then it's also a very straightforward matter to produce electricity underground. That's application of existing thermal machinery and storage and a battery system. So we're contemplating a charging station run on a cryogen for electric vehicles underground. Now, there are other aspects of this, and one of our partners, the Dearman Engine Company, is currently developing a larger engine which runs purely on cryogenics. And the current belief is that it's competitive with electric vehicles. But think about that. A vehicle that can be driven around underground that takes about 1/3 of the cryogenic energy as power, and the other 2/3 as chilling. So you could have a 50 kilowatt vehicle that's providing 100 kilowatts of chilling as you're driving around. This is the essence of the cryogenic system. You get cooling and power. So there's a double benefit that can be achieved from this, which we have been calculating as a real bonus, and it drives down the price. So Thank you for taking the time to listen to this short video about cryogenic energy and cryogenic energy storage. We think that the opportunity to provide chilling to the mine via cryogenics is a global industry, and the opportunity to be able to demonstrate this to mining partners and attract industry partners will allow us the opportunity to leverage any funding we've received through the government agencies that have already approached us um, to expand the current project that we're working on. So I appreciate this opportunity, and thanks to Integra and Goldcorp, and have a great day. Cheerio.